Hello, everybody, and welcome to Saturday morning coding. Um, Let me fix this camera situation a little bit. It's still too high. No. Okay, so we are gonna continue with the with the learning image processing, and this small didactic library without pretensions of making it useful for any type of thing other than learning image programming. Yeah, I mean image processing. Sorry. Yeah, and yeah, this is it. So today we were gonna check out the contrast enhancement situation, but for that we need an image that has poor contrast to see how we can fix this. Yeah, this is very clear. So let's figure out a way to let's figure out if I can use some tool to create an image which is black and white with poor contrast. So yeah, I have just an image, the image with which we are gonna work today. It's this. This is the regular image with good contrast, and this is the same image with low contrast. The idea of low contrast is easy to understand. So basically, and why I wanted to introduce. Let me get the iPad to explain this. Yeah, the histogram is a good tool for understanding this concept. So. So as you can see, the image, I'm gonna switch now to the iPad. So because this is easier to understand. Uh, Oops. Where do I have this? Okay. So yeah, now you can see So if a usual way to represent a histogram is to represent the levels of in a graph like this. Oops. I don't know if you can see it. Yeah. I don't know why this failed now. Yeah. Technical issues with the okay. Let's see. Hello everybody and welcome to Saturday morning coding. What is going on? Okay. I don't know why that video started to play. I was fiddling with YouTube this morning, so sorry about that. Okay, now finally. So a good a usual representation uh, of the histogram is it so these are the different levels of gray. We are talking about monochromatic or grayscale images, and this is the amount of pixels. So we can measure the contrast by measuring how dispersed or concentrated are this function. So obviously it's a discrete function, but we can still draw it like as if it was a continuous function. So yeah, basically regularly, for example, in this image that we are going to use as an example, there is a region that concentrates most of the pixels. So it would be something like this, whatever. While in an image with high contrast, the pixels would be more evenly distributed throughout the whole thing. So one thing that can be done in the image is to increase the contrast, is to do something that is called histogram stretching. So we manipulate the values in the according to the histogram in a more or less mathematically sound way. So we expand the function, keeping the information as close as possible. So I mean, by information, I mean keeping the distribution as close as possible, but just use the whole space of gray levels. So yeah, that's why we needed to introduce first the idea of the histogram before starting to talk about contrast enhancement. So this means that we need to come up with some sort of function that goes from this space to the whole space in a sound way. So we need to map somehow these pixels to these pixels. Of course, when you go from a smaller group to a bigger group, there's no issue, except that the pixels that originally are in this area, the information loss will come from the pixels that are originally in these areas that will be messed around with. But yeah. So yeah, what is the way to do this? We can start with one of the easiest ways, which is equalization, which basically takes in the more strict way would be mapping minimum maximum of the histogram to, in this case, 0 to 55, which is all the levels of gray, with a linear relationship. So this is the most basic way of doing this, and it's not the most perfect one, but we can start with this. So this is a very basic operation, but at the same time it's a relatively clever way of manipulating the information. Like, that's the thing about many times what happens with image progressing, that are ideas that are so simple, but then you need to come up with a sound way to actually, explain them, because visually you see when it's very easy to see when an image has low or high contrast, but it's not so easy to manipulate the image, or mathematically the data, let's say. So yeah, this is the original image, and this is the image that we have with lower contrast. So let's see. We can just create a new package, new Python package, contrast, and here we can say, well, we can call it a new file. So obviously the first def linear, how can I call this? Histogram equalization linear. So this receives an image, and also image, and returns another image, and yeah, and for this we definitely need the histogram. So from histogram import histogram. So obviously, as usual, this is only for black and white images. So if the image mode is not L, we just get out of the way. I don't know. I honestly don't remember the my God, how do you say the exception hierarchy? So value error might not be the best for this case, but it's okay. If not, new image equals a image of the size of im.size. Wait. How do you fuck's sake. It's a static method, I think. Image.new, yeah. Mode L size says same as the image. And what is the third? Color equals 0. Color, I don't care. I really don't care about the default color because I will be painting it anyway. So in size. So now in we get the pixels from the original image and the new image pixels from the new one, because this is gonna be pixel manipulation, so we need these pixel access objects from the and now once all this is done, we get the histogram. We can call it H. Well, histogram of the image. Let's get histogram. My memory is so bad. Luckily, I have a good idea that helps me with that. It's not import histogram, forget histogram. So now we have, and we are gonna add a new histogram utility here, which I'm gonna call the get extrema. Which gets a histogram, which is a list. And returns a tuple, which is the maximum and the minimum of that histogram. So what is this gonna do? It is gonna get the minimum and maximum. By minimum, I mean the minimum number that minimum number that has at least one pixel in the image. So yeah, minimum one for current value in value 256. Oops. If list if age of current value is different from 0, then mean for current value range mean equals current value, and we break. So this should give me and this should max equals max equals -1, and then we return mean max as a tuple. This requires two lines here. Yeah, I'm yeah, obviously it's complaining that that I cannot call this, or I shouldn't be calling this min and max, because those are functions that exist in the language min and max. So I don't want I cannot use the mean value because I don't want the minimum value. I want the index that contains the minimum value. So in range 256 to 0 with a step -1. So in this case we got we go, I don't know why I pressed. So we use the range to go from 256 to 0, and then if current value, then we have so now we have the extrema of the histogram, the first value which is not 0 from the bottom and from the top. So now we can do in the contrast. Yeah, so now extrema equals to get histogram and get extrema. Oh, I know, from histogram. Yes, because we are going to the histogram package, but then inside is the histogram file. So I'm not fully convinced with how this ended up being in the process of. Yeah, there was a lot of discussion in the Python community about importing packages that are at the same level in the hierarchy or higher, and yeah, this is how I do it. I don't know. I don't really fully like this, but yeah, this is how we go with it now. Name is basing the stuff. So anyway, so now we need to map. We need to do this. So back to the iPad. So we have a, I don't know how is this in English. Cross multiplication. So we have to do this from and how we do this. This is a cross multiplication. So we have the mean goes to max as 0 goes to 255. So it's a direct cross multiplication, so it's easy. So it should be no, it's not this. Wait. A linear relationship. So let me think a little bit of the maths according to this. So we need to redistribute this. So we have that um, um, mm, so we would need to do so the new value, I'm gonna call it G is the gray level. So the new gray level equals the oh God. Jesus Christ, why it's taking me so long to think about it. We need to just scale this back. So we will need to do current gray level minus minimum divided by maximum times 255, I think. So if we are going from 0, 1 to 0, 255, this would mean that we would have, for example, 0.5 minus 0 divided by 1 times 255. And this would be 0.5255 would be 128. Yeah, I think this is correct. I think this is correct. If the gray level is the minimum, then we get to 0 divided by max times max is 0. And if the gray is maximum, if the G is maximum, then maximum minus minimum, we shouldn't. Oh, it's not. Okay. This is okay. Let's see. I'm trying to find out because that we need to get we need to scale. We need to go from this map. Yes. Yeah. I'm trying to find okay. So we should do considering G the grade level. We should do G equals minus minimum times max minus minimum output. These are the from the okay, now I understand when I'm getting stuck. So this is the input. Yeah, I was mistaken. So yeah, minimum of the input range of this range, and this is max of the output range minus min of the output range in max of the input range minus min of the input range times min of the output range. And this now we can simplify a lot because output range minimum is 0, so this goes away because this is 0, so and this is 0, so so now we need the real thing that we need to calculate is G prime equals G minus minimum times maximum 255 divided by minimum minus maximum, no, maximum minus minimum, sorry. And this should give us the proper new gray value. So if this is, let's say that we are going from 10, 100 to 0, 255, then if I substitute and we get 1020, so we can get the 15, which is the middle of the range. So 5 times 255 divided by 10, So this would be, if we get a 15, this would be equals 15 minus 10 and 255 255 20 minus 10, so it would be 5 times 255 divided by 10, 5 times 25.5 is 125, 127.5, 128. Yeah, this works. So now we can do for x in range size image.size 0, for y in range image.size of 1, then we get the value in the image. So in value equals original image pixels of x and y, new value equals value minus extrema of 0, which is the minimum, times 255 divided by extrema the 1 times extrema of 0, and the new image of x and y equals the new value, and then we return new image. Okay, let's see how this plays with an example from spi.contrast import histogram equalization linear, and then we do em2 equals histogram equalization linear of in, but we do this with the low contrast image, and we just save it as having linear contrast, for example. But this needs to be image 2. So we are ready to test this and see. Maybe we have made a mistake. I wouldn't be surprised, because I don't know why this math took me so fucking long. Okay. Oops. Yeah, of course the image is not grayscale. In equals to yeah, from spi dot utils dot conversions import dot utils dot color utils import. Where is the conversions? RGB gray. RGB gray image equals RGB gray of image, and now we can read. Yeah. Okay. list index out of range, so we have made a mistake in here. Okay, yeah. The start value is included, so yeah. Yes, this is the other yeah, of course you need to round this because it cannot be float. And I made a mistake as well here, it's not multiplications. Okay. So this is the contrast recovery that we just created from this. We came to this, which I have to say that is pretty good. so as to, oops, I forgot to, oh no, you haven't seen, like, you have seen only my face. Okay, sorry. Yeah, so yeah, I'm gonna go through again because, yeah, well, I was just correcting couple mistakes that this needs to be round because this needs to be an integer, so and this is not multiplication, this is subtraction, so I corrected that. And also I wrote this main, which basically just takes an image, converts it to grayscale, does the histogram equalization linear, and saves the image. So we went from this, as you can see, low contrast, to this, which is with our contrast enhancement. And this is actually fairly close to the original black and white image. It might not be exactly the same pixel wise, but our recovery was, I would say, pretty good. Our contrast enhancement compared, once you get this very low contrast. And yeah, this is just one of the ways. There is many more clever ways to increase contrast, like adaptive and just even detecting region to increase the contrast in one region and not in others. But basically, this revolves about the idea of the, you know, it's a statistical idea. You just get the distribution of the pixels and you see, okay, where are these pixels and how can I make them mm, be more, like, have bigger differences between them. And this is one way. So if you have a low contrast in black and white image, of course, this is when learning image processing, it's usually you usually start with black and white because just because it's easier to understand. There's only one channel of information, and but of course you could apply this to color images. I don't know how well it works if you apply to every channel independently. You do independent independent histogram equalization on every channel. I have absolutely no idea because well, in RGB it probably works because RGB is a cube, the color space is a cube, so the distances work kind of naturally. But but uh, but in other color spaces that have different shapes, you cannot rely on this kind of manipulation, so it's a little bit difficult depending on the color space. That's why you usually use RGB, or I mean, usually use RGB. You usually use grayscale, 1 byte per pixel, 1 byte per pixel stuff to learn this kind of techniques. But the thing is that this is a very, very basic, and also I like to do it in Python because we are not trying to get like super optimal performance. You can use I mean, it's very easy to understand, like language-wise, and it's almost like pseudocode in a way. So I like to do it like this. And yeah, what else can I say? That yeah, you get this is the final result of what we have gone through today. Very basic contrast enhancement algorithm for grayscale images. This was the original images. This is the one that we have ended up with, and yeah, this is the original black and white, and this is the original color one. So yeah, yeah, this is what I had planned for today. Do you have any questions or anything like that? The math took some time, took some time to get it right because I don't know. It's Saturday morning, so I'm not like fully 100%. My brain's fully working, so yeah. Uh, this we have done like a histogram equalization, basically redistribution of the pixels to increase the distance between the colors. So that's a pretty, how to say, uh, pretty complicated way of say basically contrast enhancement. Yeah, it worked. It worked kind of well. Um, but yeah, any questions or any uh, whatever, anything that you want to get to know or ask, that yeah, this is what I had for today. So yeah, the worst case scenario obviously for an algorithm like that is that yeah, that I mean, it can only do so much if in the low contrast image the pixels are too very close, then they will be slightly farther away, but it will still be low contrast. So this is not a foolproof method, but it's still something that is very easy to implement, and it kind of works for many cases. So yeah. Mm, so yeah, I see that. Well, as you can yeah, you can follow me on my social media. I will write in the chat my handle on Twitter. Um, these are all in YouTube in my channel, which is my YouTube channel. If you want to see past episodes, um, think this is my channel, I think, and this episode will be uploaded as soon as I finish recording it, and And yeah, thank you for passing by. This is all I had for today. Easygoing contrast enhancement, and yeah, this is it. Thank you for passing by, and hope to see you around next weekend. And see you. Bye.